What's up, animators? Sharp here, and welcome back to part 3 of my Abandoned House Beginner Blender course. The name is still very long. In the last part, we've modeled this wonderful house on the journey of creating this beautiful scene of said house in the abandoned forest. Now, although last part got a bit speedy towards the end, I did explain everything you need to know in order to create that, so hopefully you're able to follow along. I'm actively answering questions in the comment sections below, but I also have a Discord server where you can share your progress and ask questions and tips. We're all a very helpful and open community, so join us if you have any questions or you want to share what you've made. This part of the course, however, we're gonna have a crash course on texturing, because in the next part I'm gonna teach you how to make trees and we're gonna dive into textures. But there's a few things you need to know before we get onto this, so this is what this episode is for. If you've been enjoying this course so far, I want to ask you to drop a like, hit the bell, help me out, you know, casual YouTuber stuff. But for now, let's focus on the actual thing. I've opened up Blender, and if you're interested how I have an empty scene here, you can delete everything in the scene and then drop down File. And then in defaults, just click Save Startup File, so this is going to be your startup file every time you open Blender. Or you can click Load Factory Settings and go back to the way it was before. Okay, so how does texturing work? Okay, let's add a cube, for an example, and give it a material in the Material Properties tab. Add a new material, I can rename it Test, for example. And in here I have the information about the material. So let's say if I give this a red color, we're not going to see it until we hop into Viewport Shading mode. I like to use shortcuts, so press Z and it's down here. So in the material mode, you can see what the material is. And in this episode, I'm first going to tell you how materials work, what the inputs mean, and then I'm going to tackle UV unwrapping. Okay, so you have all the settings of the material here, but when you're working with textures, it's easier if you open the shader editor. So I'm going to open up this window. I'm going to open a new window here and change this into Shader Editor. Okay, I'm gonna press N to close this stupid sidebar. It should be off by default. I hate this. Okay, so this is the material. I am now in version 4.0. Some parts of this have already been recorded in version 3.5 because 4.0 wasn't here before. So I'll show you how all this works. It's slightly different, but it's pretty much the same in 3.5 and in 4.0. A bunch of stuff just got hidden inside dropdowns and it's organized a little bit differently, but it's essentially still the same thing. There are a few main things you need to understand here. Actually, I'm going to delete this cube and I'm going to add a plane instead. It's going to be easier to demonstrate. I'm going to scale it up, and instead of adding a new material here, I'm just going to click this drop down and give it the material we already have. So first things first, we have base color. This is the color that your object's going to use. This is a node-based system, and nodes have inputs. So you could import an image. Actually, hold on, let me click on one of the export folders and just bring in a texture, the rendered texture that I've already made for this. So let's drop this in. This is our image texture, and I'm gonna plug it into the base color. And as you can see, it's projected on here. It does look wonky. That's because if I hop into UV editor and edit mode, you can see this UV is stretched. The face is square, but this is a rectangle. So we had to scale this to the same shape. It would be normal, but we'll get to that later. Let's talk about the material first. Let's just ignore the fact that it's stretched, go back into the shader editor. Let's talk about the inputs. What do the inputs mean? Base color is self-explanatory, like that's the color. One thing you have to do, this is mandatory, okay? When you're working with textures, it's very useful to turn on Node Wrangler add-on. This is something that comes pre-installed with Blender. It's already on your computer, so just click Edit, Preferences, and then in the add-ons section here, you search for Node Wrangler, this thing down here, turn it on. That's mandatory. If you don't turn this on, you're not allowed to make textures, okay? This is the law. I don't make the rules. No, but seriously, it is a very useful thing. I don't know why it's not on by default, because everybody uses this. All this does is it gives you more shortcuts, so it's easier to make node magic faster. That's all it is. Without this add-on, you'd have to disconnect this. With this add-on, I could just hold Control and right-click, so I can cut this. Anyway, I'm gonna add a UV sphere. And I'm gonna give it the same test material. I'm gonna shade this smooth so you can see. And what the metallic does is when I raise metallic value up, it's gonna shade it more like metal. What it does is it changes the IOR, which is the index of refraction. This works on a similar system than how actual light behaves in real life. By raising up the metallic value, you're changing the index of refraction, so it's shaded like it's made of metal. You can see what it does, really. Next up is the roughness input, also a very important one. Metallic works in a way that when it's 0, it's not metallic. When it's 1, it is metallic. Roughness describes the roughness of the surface. For example, if we take a look at my phone case and I try to angle it towards the light so you can see, like, it has little bumps on it, right? Every material has microscopic bumps on it. The more rough it is, so the more bumps it has, the more rough it is. If you raise the roughness up, the more it's gonna diffuse the light. All the reflections on the object get very blurry because they get dispersed into all the different directions. So if we put the roughness down, this actually becomes more shiny because the surface is not rough, it's very smooth. So it's reflecting light unblurred. 0 means reflective. 1 means very diffuse. This here is index of refraction. We usually don't use this unless you're going for very professional photorealistic stuff. It's difficult to understand. This is the IR glass, this is alcohol, acetone. Every material has its own index of refraction, so you need a list if you want to stay close to the physics and stuff. It's mostly not used, but it changes the angle of refraction and stuff. Don't worry about it too much. Now we have alpha. This is basically transparency, and we're not gonna see it because of the viewport shading. So in the material properties tab, you scroll down, and in the settings down here, you change the blend mode to alpha blend. This is now, you can tell it's dropping down the opacity. When you hit render, it's always going to make it transparent, but if you want to see it in the viewport, you have to turn this setting on. There's also alpha clip, so it clips it when it gets below 50. Alpha hashed kind of disables you from seeing the back faces. That's just different preview modes. Next up, it's normal. Now, I've talked about face normals before. Let me turn them on right now. See, every face has a normal where it's pointing. But with a normal map, you can use a texture to influence little tiny bumps that are not actually there on the model. I'm gonna get a quick example. I'm gonna use the textures from the same project. Okay, so wait, this is the normal map. And if I hop into UV editor, this is what a normal map looks like. It's typically blue with shades of cyan, magenta and stuff. This is like a 2D image using each color to tell you what the bump looks like. So anything from the right gives you magenta, from the left it gives you cyan. Based on this information, it gives you bump details. Let me try adding that. So the normal map is something you don't plug directly into the normal map because it kind of ruins it, as you can see here. Because an image texture has a yellow output telling you this is a color output. It gives you red, green, blue color image. But the normal map has a purple input, which is a vector input. It needs a vector. That's why we add a normal map. So press Shift A to add a new node. I'm gonna search for normal map. Boom, here it is. And what this does is it translates a color input into a vector output. So if I put the color into the color here and put the normal of the normal map here, this now gives us fake bump informations on the sphere just by using the texture. So it looks like it has bumps. It doesn't actually give you bumps, right? This is still completely flat. It's a texture that influences normals. So it's a trick that lights it in a way as if there was a bump there, but it's not actually a bump. To make this work properly as well, this image does not have color information. It has normal information. So we put the color space to non-color. Each device in software has a different way of reading colors off of an image and displaying them. And color spaces are a tool that can translate those languages, right? So we have to tell Blender that this image, it's not giving us any color data. So when you put this on, it's going to be read differently. If you want to preview what it looks like, because we have, remember, because we have the Node Wrangler add-on, because we have it on, we can press Control Shift and click on any node, and it's going to display just that node. See what it does? It connects it into the material output, so we can see just that node. This is what it looks like in vector information, right? This is plugged into the normal input, so if we preview this, again, Control Shift click, this is what the whole material looks like. So with the color, with the roughness, with everything. So if I raise the roughness up, it still has the bump, but it's not as reflective. If I drop this down, it's reflective. Nodes like this usually have a slider, right? So if I drop the strength of this, the bumps are less intense. So there's just a little bit of bump there. So you see how you can use this to manipulate the material. Usually we use textures. So because I've imported this texture, let's try it with the base color as well. Usually it's called diffuse or albedo. This is called diffuse. It's called diff, right? Bark Willow 02. Diff stands for diffuse, and 2K because it's a 2K resolution. This is a texture that I use later on in the project, so it's kind of fitting that I'm showing it right here. This texture uses color because it's the base color, so we just leave this on sRGB, plug this color directly into base color, and now the color information match the normal. So if I put this back to 1, you can see like It has the cracks everywhere. Roughness is still too rough, so we also have a map for roughness. This one is the roughness. I don't know why, but I've downloaded an EXR file instead of a PNG file. It doesn't matter. Usually roughness maps are PNG. I'm gonna put this in and get rid of this one. But the roughness map also doesn't give us any color information because roughness maps are black and white. I'm gonna go into the UV editor, up here select the roughness map so you can see what it looks like. It's very white right now because of Blender's color transform, but there's traces of gray. So it's a 0 to 1 map, basically. Up back into shader mode. If I Control-Shift-Click to preview this, it's barely visible, all right? Let me add a color ramp node so I can show you what it looks like. And if I crush the blacks, you can see more of that information. This is what a roughness map looks like. And we've said before that roughness, when it's at 0, it's reflective. When it's at white, it's not reflective. So if you plug an image into the roughness input, this is a black and white image. Black is 0, white is 1. This is the same input. Let me get rid of the color ramp. Control-Shift-Click. This roughness map is mostly white, which means the roughness is almost 1, so it's not going to be very reflective. Let's plug this on non-color. It doesn't have color information. Let's put this to non-color so it's read properly. Let's put the color into the roughness. So now the roughness is not completely even because it has some darker spots. So some parts are going to be more reflective and some parts are going to be less reflective. Let's see this by previewing the material. It's mostly white, so it's not reflective, but it has some variations in reflection. This part here feels a little bit more reflective than the rest. I guess it's easiest to show if I bring back the color ramp. Let's put this in between here. Let's bring the black parts up. This is slowly more reflective now. If I disconnect the normal and the base color, and if I put this onto black so it's more visible, you can see that not all parts of this object are equally rough. Some of them are more glossy and some are more diffuse. If I bring this up even more, you can see like there's a strong divide. Because if I preview this texture, you see black parts are reflective, right? If I bring the white part even closer, you can really see the difference. So black and white. Black and white. So you can use one slider for the whole material, but a texture affects different parts of the shape differently. So if you plug the texture in, it's rough in some areas, but not as rough in others. You know what I mean? Okay, let's plug everything back. With the normal map, boom, you got the bump details as well. With the color, boom, you have color detail as well. That's how you make materials. But the reason that a UV map is important is because if I go into the UV editor, you know, edit mode, and if I mess with the UVs, they're now choosing different parts of the texture. If I come in here and change this to the diffuse, right? So we can see what parts of the texture we're seeing. If I click this arrow with the icons up here, it's gonna link the selection. So if I click on these faces, I select these faces. So these are the same faces. This right here is the UV map for this. So if I move these faces around, they're using a different part of the image. Because if you have a 3D object in a 2D image, how are you going to wrap that 2D image around it? It doesn't make any sense. And this is the image that best describes it. So this is a chocolate Santa, and this wrapper kind of works the same way like UV maps work. You have a 3-dimensional Santa that needs to be wrapped in 2-dimensional foil. The foil is kind of folded out, so when you wrap this foil around, it's gonna draw the shape on the Santa. Let me try to find a better example. Let's delete the sphere and add a cube. Each primitive object you add has automatic UVs already done. I'm gonna mess this up by projecting this from the view, I guess, so it's all messed up. Any model you modify doesn't have any UVs. Let's try to apply the same material here. And it's kind of messed up. You can see it looks fine from this angle because that's how I projected it. So let's just deform the UVs even more, right? This has UVs that are completely messed up. So how would you fix those UVs? How am I gonna get this 2D image wrapped around my 3D cube? We have to UV unwrap this. So imagine like you have to slice this object up and unfold it. Once it's unfolded, you can project a texture on it. This 2D texture goes on top of it. And once it has the texture, it's folded back in. That's how it works, except we're not physically slicing this up and unfolding it. It's metaphoric. Okay, so let's go into edge mode. And if we had to slice this thing up in a way that it's able to unfold onto the floor, I would probably cut these 3 faces, right? And if this was actually a cut, this top face could just flop over like this. It's not actually cut. I did some trickery there. Okay, so this top face has now been cut. Let's see, what else can we do? I would also probably slice the bottom one out So the top face and the bottom face should now be completely sliced apart, and they would be connected on these two edges, right? So this circle in the middle, this row of these four are connected everywhere. So this is like a ring. You can't unfold a ring because it's holding on. So let's pick any of these edges, any edges really, and just slice this up as well. Oh yeah, by the way, if you want to cut, select the edge, press U and click Mark Seam. That's how you do it. Mark Seam. So you place a seam, which is a cut. And what I've done is I've right click and chose Add to Quick Favorites. A quick favorites is like a menu. You press Q. This is all your favorite operations you've saved. Mark Seam is on the top, so I can just Q click to add the edge. It's very cool. So U, Mark Seam. Or you can right click and add it to your favorites, so you can also Q Mark Seam. Okay, once again, so this face has now been cut out. All the red ones are cut. So this has been cut out, only connected here. This has been cut out. So now we have this ring to deal with, and we've chopped it up. So this could unfold, this could follow, this could also unfold, and these two would just come off around. So if we placed these cuts, this cube should be able to unfold. Okay, so let's select everything by pressing A, press U, and then click Unwrap. This will attempt to unwrap it just like if these were actual cuts. Now, what happens if I place another cut here? Let's add a cut here as well, and then unwrap it. We get two pieces, so these two are completely cut off from the rest of the model. So now they stand alone, they're not touching anymore. So this is now a whole different piece. We call those UV islands because this part is not connected to anything else on the model, but all these still are. I could place another cut here, and now this face has completely been cut out. So let's try to unwrap this. This face is now completely separate. These two faces are completely separate. If I try to select them by linked, it's only gonna select the insides of the UV seam because they're separate, right? I've now chopped it up into many different parts, and I can pick which parts of the texture they're gonna choose. One problem arises here, and it's in the edges. See? This part of the texture is not connected to this one. There's an obvious seam going down the middle. That's why we say mark seams, because that's a seam here, right? The texture is not just floating from one side to the other. This edge is not a cut, it's not a seam. The texture is flowing, you see? It's the same part of the texture going onto the other face. That's because this is the part of the UV map which is still connected. But wherever you cut it, that's this edge. This edge is this edge up here. It's impossible to keep that connected because that's how UVs work. But if you don't place these cuts, it's impossible to unfold the model. So when you make UV maps, you need to try to hide those seams. You need to place enough of them so you're able to unfold the model, but you don't want this ugliness like this. You don't want this to be in plain sight. That's an art form in of itself. Once you have the UV map, you can decide which part of the texture it will display, and you make the texture in the shader editor. We made this wood texture. I think it makes sense so far. We've got the base color texture, we have the roughness texture, which tells it how rough it has to be. We have the normal map, which tells it where to place bumps. We have the metallic value for when things are made of metal. Then the next bit is subsurface scattering. The best way to explain is with the same example that everybody else uses. Imagine you shine a light through your fingers turn red because light is shining through your skin. When it does travel through the skin, it picks up on the color of the blood in your skin, right? So it shines orange, but it comes through the object. That is subsurface scattering. Let me just add a light for demonstration purposes and put it up to like 4,000 or something. I'm gonna hop into a render view. You don't have to know about this yet, but this light is very strong, as you can see here. So if I give this object a little bit of subsurface scattering by raising up the weight here, you can see up here this red line. This is light bleeding through the object, right? This is what subsurface scattering does. Light is trying to shine through it, and it's taking the normal map into account. So where there's a bump, there's less light going to be piercing through. You can also affect the radius. So this is red, green, and blue colors, RGB, because we're working with light and we're using additive light mixing. So this is what that looks like. So you see, if you mix red and green, you get yellow because that's how light works. So let's put red and green both to 0.5. We get a yellow tint, right? Because these values are identical. If we put all three to the same, we just get white, because mixing all three gives you white. Remember this additive light mixing. So let's say we want a magenta. So let's just get rid of all the green, because red and blue together create magenta. We get magenta shading. So this is wood. So realistically, we would have like a yellow, more orange tone. So we need more red than green, but we need both red and green. So let's put this to 0.3. But this is orange. Even less green, 0.2. Okay, sure. This is the radius, how far out it goes. So if I put both of this to like 5, you see it really bleeds through the object. That's subsurface scattering. Let's turn this off. And the next part is gonna be specular. We know roughness. The less rough it is, the more reflective it is. Specular is the amount of reflection. Okay, so it gets a little confusing here. We don't usually touch specular, so you can ignore it. But if you want to understand, I'm gonna explain. Specular is usually the amount of reflection, and roughness is like the sharpness of the reflection. So the less it is, the more sharp it's gonna be. Specular is like the amount of reflection. So when I put this down, there's no reflection wherever. Usually you put this on 0.5, keep the default values. You don't have to know unless you're a material scientist. We're not gonna touch that in the course. It's fun to explain. Next up, we've got transmission, and this is basically making your object transparent, like see-through. This is like glass, right? Let me add a light again and hop into render mode so you can see what this does. This is like glass, it's transmissive. This is what that does, so let's put this off. Then we've got coat. It's like adding another coat on top. This material is reflective, it's reflective wood, but it has a rough coat on top. This is good for car paint and stuff like that. It's like having a physical layer on top of the material. You know, this is the weight, how much of it is present, and this is the properties of that coat. You can also tint it. I tint this red. There's a red coat on top of my wood. You see what I mean? Okay, now we have sheen. Sheen is like, sheen is good for fabrics. It brightens the edges of things, including your texture, so it makes it feel more fuzzy, like fabric and clothes. And finally, we have emission, which will make your object glow and emit light. So if I place another cube in here and delete my light, this cube is now illuminating the other cube because it's emissive. Okay, back into material. So these are all the inputs. We've covered UVs and how they work with textures, so they choose a different part of the texture. What I haven't explained is if you scale anything beyond the UV, the texture repeats, right? On the edge of this texture, like this texture repeats endlessly in all directions. The reason you can't see the texture repeating is because I have a seamless texture. Those are special textures created so the top and the bottom of the texture is the same, so they just connect flawlessly. But if I do something like I did before, so instead of this material and instead of this base color, I try to plug in, say, you know, my render once again. I plug this in instead. And if you take a look at the UV editor, you know, I've scaled this so many times, the image will repeat endlessly. Unless you can go into the shader editor and tell this not to repeat. So we have this repeat thing. So you can say extend. After this image comes to an end, it will just extend those same pixels endlessly. If you have a tiny bit of the texture just overhanging, you can extend it to make it seem like it's going. It works better on small surfaces. You can also make it clip. So there's only this texture and it doesn't repeat ever. Or you can mirror it. So it keeps flipping on itself, you know, going back and forth. It's mirroring if you want to seamlessly extend something. But not all materials actually follow a UV map. So let's add another cube. Let's completely destroy the UVs, right? Let's completely jam it up. If I give this the same texture, it's using all the wrong parts, it's completely gone. If we use textures on this, it's gonna be bad. But there are ways to texture without ever needing a UV. And this is where procedural texturing comes into play. So let's add a noise texture node. Let's plug the factor into the base color. And this looks like a random noise. Okay, now because we have the Node Wrangler add-on, we can just click on this and press Ctrl T, which will add the mapping and texture coordinate nodes. This is where we get to pick what is going to be the coordinate system for the texture. We could plug it back onto UV, which would completely destroy the texture and stretch it because our UVs are awful, but we could put it on object. This will take the coordinates of the object. If I preview this, this is what those look like. From the center of the object, if you go onto x-axis, you get x value. So this is the red value. X is red. If you go up, you get z value, which is blue. And if you go away, you get y, which is green. So RGB, once again, the same. X is red, Y is green, Z is blue. In this bottom corner here, you're getting red, you're getting green, and they mix together into yellow. As soon as you start adding blue, you get white, you know, the mixing. Based on that, it knows where to place the coordinates. So if you preview the material, it's always going to be on the object. You don't need UVs. You can mess with the scale here. You can also, you know, give it a color ramp node in between. I also have it under quick favorites because I use it a lot. And you can crush it down a little bit like that, so it's more intense. Then you can increase the detail, right? Slide this up and it's much more detailed. Increase or decrease the roughness, so how much is going to bleed onto the other parts. Something like this. You can distort it so it's wonky, and then you can use this as a driver. Like now I can plug this into the roughness, and this now has small imperfections. Okay, what else we can do? We can add a wave texture. Control T to give it a mapping node, use object, and then plug this into base color. So what does this look like? Well, it looks like this. It's giving you a wave. We can choose either bands or rings, and it's like this. If you want to change this, you can use the mapping node to rotate this, like say on the Y. So, oh, it's up here now. You can also change X, Y, Z, in which direction they're here, or diagonal. You can change the type of fall off on the rings. You can change the scale. You can distort them a little bit. You can give it more detail, you know, just like before. You can mess with this as much as you want, and then before you plug it into color, you can also give it a color ramp. And let's say, like, this looks like a wood texture in a way, right? This looks like the texture of wood. But let's give it some wood colors. Dark like this. I'm eyeballing. This is ugly wood. But okay, let's say this is wood. Why not? Let's get rid of this. And then we already have this information, right? We already have this black and white information. If we put this through another color ramp and preview that, we could use that as a roughness map. Okay, so we know the wood is not very rough, so it shouldn't be black. So let's raise this black up to like 0.7, and let's drop this down to like 0.8 or something. And if we plug this into roughness and preview this now, yeah, okay. What else is missing? Oh, we need bumps, right? Wood. Let's plug this into a bump map into the height input, right? So this will change a black and white image and turn it into bump information. So if we plug this into normal, wait for it, boom, we get bump information. We can also drop down the distance to make it less intense, and we have a really quick, really sloppy makeshift wood texture, for an example, without any UVs. Because if you remember, our UVs are still complete garbage. Why am I showing you this? I want to show you how texturing works. UV unwrapping, using textures, and then picking which parts of the texture you want. Sometimes people would make UV maps of multiple objects, put them together. Wait, actually, I have something to show for this. Wait. Okay, say here, I made a UV map for different parts of my model, and then I custom painted a texture so it was made specifically for the UV, right? Like, let's take a look at this, for an example. Like, this is the base color for the arm. It's a custom texture that specifically fits my model. So these stretch parts here, this is in between the different UV islands, right? But here, like this big blob, this is where the UVs were on my model. So this texture got projected. So this is the base color. I also made a height color, so for the little bumps, right? I also made a metallic map. So these yellow bits up here were also metallic. All of this, which is black, was not metallic. All of this, which is white, is metallic. Then I made an ambient occlusion map. This is also very fun. Hold on, I can show you that as well. Ambient occlusion, and this is diffuse. Okay, so we have this here. This is my base color, and this is the ambient occlusion. Ambient occlusion is where light would normally dim out. It's like a shadow. Ambient occlusion is a shading and rendering technique used to calculate how exposed each part of the scene is to ambient lighting. This here is a nice example. This is the scene. This is the ambient occlusion. So the dark parts are naturally going to be dark because they're not exposed to ambient light that bounces up. This is without ambient occlusion. Bottom one is with ambient occlusion. And we also have ambient occlusion for different textures. So if I have this and I want to mix ambient occlusion to this, I can. Okay, so I add a mix node, put this into socket A, put this into socket B, and it looks very ugly. Why? Because ambient occlusion gets multiplied on top. Remember, white is 1, black is 0. If you multiply anything with 0, you're always gonna get 0. If you multiply anything with white, you're gonna get the same number back. So if you multiply this on top, only the black parts are gonna be applied. And if you raise this factor, you can see the black parts being multiplied on top of the image, right? That's why you multiply it and you use this in the base color, so now it feels like it has more depth than before and stuff. Let me split this window again, read my UV editor. Okay, so my point is, we add UVs so we can project textures onto them. Sometimes we use tiled textures like this, where you can just scale endlessly and you're just gonna get a wood texture regardless, because it's a texture of a material. In other times, we paint custom textures, specifically designed for a certain model. So we can really crank it up, we can add moss everywhere, we can add ambient occlusion, we can add all sorts of different little details on every part because it's specific to this model. We are partially gonna do that with the house as well, but in a different method. And sometimes you don't need UVs at all because you can texture things procedurally. Okay, if I mess this up again, you could technically also project an image without UVs, but it doesn't look that good. So instead of flat, you go to box. And instead of UV, you go to object. This is now being projected from a box from all different size, which I guess it looks nice on a cube because it's boxy. As soon as you try doing that with a sphere, you get weird seams and weird glitches. You can increase the blend and it kind of blends those sides together, but you get this awkward edge still. So the best method is always to do your UVs, so you can avoid all the deformations and seams and so on. The point of this part of the course was to teach you what all the different inputs do, how to actually make textures, how UV mapping works, you know, cuts and stuff. Bonk, 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 mark seam, unfold, boom. Easy as that. Because this knowledge will help us move forward with the course. I'm using this a lot, so your homework today is to play with this. Your homework is to create a weird looking model, play around, just make anything you want. It can be a sphere, it can be anything. You can rotate parts, yeah, so it's even more difficult, right? Just make something as random as you can and then try to UV unfold it. UV editor, okay, so if I want to unfold this entire thing onto a flat surface, what should I do? First of all, I would take this whole thing and just chop it off, right? Then I would cut these parts out. So now when I try to unfold just this little bit, it's unfolded. So this part is done. Now let's unfold the rest of the thing, right? You need to get this entire thing unfolded onto a flat surface. You can obviously cut things apart so you have multiple separated pieces, but this is your homework. Unfold random objects. Learn how it works. Try to apply a texture to them. You can take any texture off Google, doesn't matter. So you can master and understand how UV unwrapping works, right? That's your homework. Until next time, until 3 days from now when we make next part. If you have additional questions, please ask them in the comments below. I will be answering, I will be helping, and please join the Discord server so you can ask for help while I don't have time. I have a full-time job, I'm not always available, and my community is eager to help you, and you can find a lot of great answers there. Thank you for watching part 3. I hope you've learned a thing or two about UV unwrapping. Do your homework, and I'll see you in part 4 when we make the trees for the scene. Thanks for watching, stay sharp.